Okay, hi everyone. So I know this may seem a little intimidating. That's why I kind of want to make a video on it because there's not a lot of videos on there. Um, so I just want to go slow. I'm not trying to confuse anybody. There's also practice for myself as well. So, if anything, cross-reference what I say, but this is just how I do it. Okay, so with LCT, right? The limit comparison test. Basically, what you are doing is that you are taking whatever's in here and you are trying to figure out which of the tests in the series is this more similar to, and using that and saying, okay, whatever return value that I get from applying the test that looks similar to the expression that I have now, I'm going to see whether it converges or whether it diverges. And if it converges, then I have to prove that this converges also. I have to say that it converges also. If this diverges, then I'm going to have to say that it diverges also. I'm going to have to say that. You cannot have converge and diverge. You cannot. You cannot. It doesn't even exist at that point, from my understanding. So that's what I wanted to really point out. And what you can compare us to is the P-series and geometric. I know for the P-series, but I believe the geometric, I'm pretty strong on that, but, still fact check. So anyways, I did this part just to kind of explain it. But I'm still going to explain it, but I feel like what people get most caught up on is actually applying it as a limit and then like doing what you have to do, right? So, first thing that I did, right? I noticed that this is two terms against one term. And so I'm like, they both share the same numerator, right? If I break this up, they will share the same numerator. And it won't change the value of anything, really. I'm keeping the same numbers. I'm not adding or subtracting from it. Like I'm not doing too much, right? So I'm like, okay, let me break this up into two. I broke this up into two. And I realized that one of the exponents is higher than the other because there's an invisible one here. So I always pick the highest exponent, right? I always did that. So I broke it up and I'm like, I have my test down here. What test can I use? What series test can I use that looks remotely like the 5 over n squared? I know that 5 is a constant. I know that. Constant basically just means any number, any integer. Sorry. So it could be 5, it could be 6, it could be 100, it can be 1 million. But you get the gist. It can be anything like that, right? So the number on the top is kind of irrelevant. It can even be 1. So then it would just be 1 over n squared if this was 1, right? So, I'm looking, and then I see the P-series. And that's why I said you're most likely going to compare it to the P-series or the geometric. In this case, I always know you're going to compare it to a P-series, but there's also another one too. It's called the geometric one. But also look up in on that as well, just to make sure. So, with the P-series, it says that if the P is greater than 1, then it converges, right? So, when P equals 2, and I put 2 is greater than 1, so it converges. That's what I put, right? But now, we only proved that this converges. We didn't prove that this is a relation to this. We didn't do that. And that's what we have to do. And that is the point of the LCT. That is like the main thing, okay? So, what we're going to do, right? What I'm going to do is I'm going to change this. I'm going to change this 5, and I'm going to tell you why. 5 over n squared. So if you take the derivative of any constant, that's 0. You take the derivative, so you just take the derivative of any constant, that's 0. If you have a summation or of infinity, actually, if you have the limit as n goes to infinity, that's a terrible infinity, infinity, 5 over n squared. So then you put 5 over here and infinity over here, that will equal 0. Okay. So if you put, let me see if I put a different number. Let's see if I put 10 over n squared. 10 over infinity equals 0. Okay, so let me just try another time. Or 10 over n squared equals, not 10. You know what? I'm going to put like 600. Let's see. And then 600 over infinity square. Sorry, square. I should have put that. My bad. Equals 0. So this means it doesn't matter what I put as the numerator. When a constant is over infinity, it equals to 0. So does the constant really matter? No, it does not. Okay? So, oh, no, don't copy, I'm sorry. Delete. Okay. So does the constant really matter? No, it does not. It's absolutely irrelevant. Irrelevant. Sorry. It's absolutely irrelevant. So, I'm going to change this to 1n squared just for it to mimic the p series right here. So, it's still going to be the same thing. It's going to converge because it doesn't matter what is on the top. As long as it's something as a constant over n to a power, then you're good, okay? Sorry. I cleared my throat. Anyways, so I'm going to change it to that, right? So with the limits, so now proving it, here's is what you're going to do. You're going to see here that they have an an and a bn. Now, you are wondering, where am I going to get the an and where I'm going to get the bn? Your an is the original summation that you have. So, n squared plus n. And then the bn is just the result, not the result, but like the simplified, like the reconstructed form of the an when you use the geometric or the p series. So bn equals 1 over n squared, right? So it says that we have to construct the limit. Mind you, this is the convergence part. Converge. This is the convergence part. Okay, so it has to say that we have to take the limit. So let's just write that down, right? I'm gonna just go off based off what they tell me. Okay, I cannot do nothing more, nothing else. Sometimes you do have to do a little bit more, because this one you have to like sit back and think about what you're gonna do before you do it. That's a lot. That's a lot to do. So 1 over n squared, right? So we have the keep change flip situation here. Let me just make sure that I label it for you guys. an, bn, and then we're gonna keep this the way that it is, change this to multiplication, and then flip this. This is the essence keep change flip. So, and it's to infinity. So Okay, so then, oh, I should, whatever. So, keep change flip, square over 1, right? Perfect. Now, we're just going to multiply regularly. So, we're just going to multiply across. So, I'm just doing it pink. So, 5n times n squared, that's just n squared, 5n squared over n squared plus n times 1. Anything times 1 is itself, so then you just do n squared plus n. Let me write my limit again. Let me see. Okay. So, now we're right here. Now, what I'm looking for when I do this is for commonalities. Look for things in common. That's going to be like your biggest lifesaver. Okay? Like n squared over n squared, that's just 1. Really. Right? So you have to look for things in common. That's my main thing. That's the main pattern that I see that gets things to cancel and it's able to simplify even more. Right? So I notice that we have an n squared here and then we have an n squared here. So your mind thinking about, okay, what's happening with this one? Mind you, we're always going to focus on what? The highest power. This is going to expand way more than this. This one is like kind of irrelevant. It's like a constant in a way, in comparison with this situation, okay? Okay, we're focusing on the highest power, which is n squared, right? If you have the opportunity to focus on the highest power, focus on the highest power. But if you don't, then that's a different issue, okay? So I see right here that n squared over n squared. Look what I said right here. N squared over n squared equals 1. Okay, so that means that if this part is irrelevant, evidently, then that means this whole thing is just 5 over 1. So this is irrelevant, and these two both go to 1. So the only thing really left is a 5, right? So as the limit n goes to infinity, 5 over 1, as we said before, there is no n to be counted. So we're just going with the 5, right? So we have to check back with our list again. Let's see. Okay, so with the p-test, we said what? That it converges because 2 is greater than 1, which it is. So now we have to go back and say, okay, when this converge, then that means this also converges as well. And it's also greater than 1 with the 5. So you would say both series, because it always has to be both series. It always has to be both series. It cannot just be one is conversion, one is diversion. You cannot use that test. Okay? Converges. Not at. Converges. Yeah, I think both series converges. Oh. With the some stuff on there. LCT test. Okay. This is my work. Both series converges with the LCT test. That's what I put. Let me just scroll back up. That was the problem. I just did this problem a little bit neater. But yeah, let me know if you have any questions. Let me know if I didn't explain things correctly. Oh, also let me just put this one. Let me, just make sure that my syntax and everything is pretty good. But yeah, I hope this was really helpful. I hope that more people can like talk about how they got things, like whatever. But I recommend looking at some textbooks and all. And yeah. Yeah, I hope this really helped. Bye.